Hi there, we are on page 39 in the packet, and today we're going to look at the final way of how you can solve a quadratic. So while you are getting to page 39, I'm going to jump back to page 30 and just, again, review with you what you've done. So the first way we started out was with factored form, and so in factored form we used the zero product property. Then we looked at what if it was in standard form. And so what we did is what we did in our previous chapters is we went to factored form by factoring, and then we could use the zero product property. So these two kind of go together. But in our last video, we looked at, well, what if something wasn't factorable? And we looked at something called the quadratic formula. So just remember of what that is. It's x equals opposite b, and then plus or minus a square root b squared minus 4ac, and then all of that is over 2a. So the final form we're going to look at is in vertex form, and the biggest thing about vertex form is when you look at it, you're only going to see one type of x. So in standard form we had an x squared and an x, but in vertex form you will only be seeing one version of an x appearing. So going back to the page we started, that I mentioned is page 39, and before we do that, remember on page 38 we talked about simplifying radicals, which is going to be a goal in this section as well. All right, so how do you solve a quadratic in vertex form? So when a quadratic function is in vertex form, in order to solve for x, you're going to need to work backwards in the order of operations to isolate your x. So we are revisiting something that you've already done in chapter 1. So this method is known as the square root method because you will always need to use the square root to get your answer. So when we look backwards in the order of operations, it normally goes, please excuse my dear Aunt Sally. Well, what we're going to do to isolate x is get rid of addition subtraction first, which we are familiar with, then move our multiplication division, and then to do our exponent, we will be using a square root. And it's when we take the square root that we will be getting two answers, a positive version and a negative version. And then from there, if there are parentheses, then we'll end with what's in parentheses. So the reason why we're going to have two answers is because if I asked you what squared would give me 9, well, an obvious answer is going to be 3, because 3 squared means 3 times 3, which gives me 9. The more unobvious answer, and that your calculator would never share with you, is that x could also equals negative 3, because negative 3 squared means negative 3 times negative 3 also gives me a 9. So when I'm working to isolate my problem, here the only thing I have to isolate is the square root. So to get rid of, is the square root, so x is isolated. So there's no addition subtraction here. Here's my wall. There's no multiplication division. There's just an exponent. So what I would do is I would use a square root, and I would square root this side. And what that check mark does is it cancels out the little 2 exponent. And then I would square root 9. And while you can type in the square root of 9 on your calculator, it will only tell you 3, and it will not tell you at that point that you should have a negative 3 version as your answer. So we're going to write our answer as plus or minus 3. So in this one, I'm going to draw my wall, and this is 4x squared, but it's 4 times x squared. So when I work backwards, there was no addition subtraction, but there was multiplication. 4 was timesing x squared, so first I'm going to move the 4 by dividing it. Cancels out here, so I'm still left with x squared, and over here I'm left with 25, and maybe you need a calculator to do that. And now to get rid of that exponent, I will use a square root, and it's in this step that I will be getting two answers. I'll attach a positive and a negative to it. So when I square root this side, this check mark cancels out the squared, so you're just left with x. And when I square root 25, that's 5, but I also need to remember that it's a negative 5. So my answer here, I'm just going to write it once like that, is a positive and negative 5. So let's take a look at this one. So before I move any further, what I really want to point out to you is what I mentioned earlier, is that all of these problems only have an x squared, whereas the other ones, they had, let's flip to a page, this had an x squared and an x squared and an x. an x squared and an x. But these only have one type of x. It's just an x squared. I never see an x. And in vertex form, you never see an x. It's just, you know, you don't see two forms of the x. So one type of x, it's an x squared. One type of x. They might be two of them, but they're both x squareds. So that's why we're doing very similar to what we've done in the past, just isolating x. So let's jump to number 3. And in this one, the fact that I have x squared on both sides just means I want to get them on one side. So I'm going to subtract this 4x squared to join the 5x squared. So that just gives me 1x squared, which I'll leave as x squared. And now to get rid of x squared, I'll move my addition subtraction because of this subtracting 12. So I'm going to add 12, cancels out, add 12. So over here I get 36. There is no multiplication division to undo, so I'll just have to get rid of the exponent by now using my square root. And remember that I'm going to get two answers, a positive and a negative. So I'm going to square root this side. That makes it just x. And then I'm going to square root this side, which my calculator will tell me 6, but it will not tell me the negative 6. And this time I'll leave them separate instead of plus or minus 6. So on the next problem, it's 2 times x squared minus 24, one type of x. So what I'm going to do here is isolate x. So I'll move my subtraction first. I'm going to add 24. Those cancel out, so I'm left with 2x squared equals 24. And this is 2 times x squared, so I do need to move that multiplication through division. So this cancel out, I get x squared, and here I get 12. And now I'm going to square root. So what's different about this problem is all of these numbers were perfect squares, so they had nice square roots. So I want to bring you back to that idea that even though 12 isn't perfect, I could find factors that are. So I might need my factor list, but I could break it down into square root of 4 and square root of 3. And then the 4 is perfect, it's a 2, and the square root of 3. And remember, when you do the square root step, there is a positive version of the answer and a negative square root of the answer. Okay, let's go to the next one. So x squared plus 10 equals 18. So another thing to bring up is when there is one type of x, this is the only time I do not need for it to equal 0. It can equal whatever I want. So what I'll do is move my addition subtraction. So I'm going to subtract my 10. Cancels out here. I have x squared, and then over here I have 8. And now to undo the squared, I'm going to square root. And again, the square root and the squared cancel out, and then 8. So 8 is not perfect, but if my list, I could break it down into square root of 4 and square root of 2. And so the square root of 4 is my perfect number of 2, and the square root of 2 will stay that way. And remember, as soon as you do that square root step, you've got a positive and a negative version. So I'm just going to put it right here. Or you could write them separate if you want. It's just truly your preference. Okay? All right, the next thing is now I see parentheses. There's still just one type of x. It might not be x squared, but it's an x. There's no other different type of x, and the same thing here. So here in parentheses, I have x minus 2 squared plus 4 equals 20. So now when I look and I move my addition subtraction, I will be moving the 4 and not the 2, because the 2 is in the parentheses, and that's actually what I'm going to deal with last. So the first thing I'm going to do is subtract 4. So I'm still left with my parentheses squared, and then over here I'm left with 16. X minus 2 squared, there's no multiplication or division to move, so now I'm going to undo that squared by square rooting. And remember, as soon as you square root, you get two answers. So when I square root this side, there's all that canceling out happens, so I'm left with x minus 2. But when I square root this side, I got to remember that there's a 4 and there's a negative 4. So what I'm going to do is when I'm ready to get x alone, what I got to realize is there's actually two problems here. There's x minus 2 with a 4, but then there's also an x minus 2 with a negative 4. So in either situation, I'll add 2, but this time I'm going to get this problem, I get 6. But when I add 2 here, I'm adding it to negative 4, so I get a very different answer of negative 2. And you're going to see that happens when there are parentheses in the problem. When there are no parentheses in the problem, then it's just going to be the same answer with a plus or minus. So let's look at this one. X plus 2 squared minus 5, so I'm going to move this subtraction first by adding. Okay, so now I'm just left with my parentheses squared and 8. And now I'll undo the squared by square rooting both sides. So here I'm just left with my x plus 6. Now over here, 16 was perfect, so I can make it 4 and negative 4. 8 is not perfect, so I'm going to go back up, which we did it right here, and realize I could break it into the square root of 4 and the square root of 2. Oh, that's supposed to be a 2. And then the square root of 4 is 2, and the square root of 2 will stay that way. But I have a positive and a negative version. As soon as you do that square root, you got your two numbers. And so just like before where I made two problems, right, I'm going to make two problems here. One is x plus 6 with the positive version of this, and the other is x plus 6 with the negative version of this. And now to solve for x in either way, I have to move the 6 over. And so when I do that, it will be through subtraction. So when I subtract here and they cancel out, and then I subtract here, these are not like terms. We have talked many times before that adding, subtracting is really picky. So since these are not like terms, I will just write down that I want to take 2 root 2, square root of 2, and subtract 6. So whatever that might be, I could type into my calculator and find out. And in this one, when I subtract 6, and those cancel out, just like before, these are not like terms, so I can't combine them, but I can still say that I want to take the negative version of this radical and subtract 6. Okay? So you do get two answers. If you want to write this as one answer, it looks a little weird, but you'll actually put the negative 6 first, and then you'll have a positive version of your radical and a negative version of your radical, and then put your radical behind it. So you could write it once, but I think it's great to write it twice. So that is our square root method.